All right, today's algebraic expressions. How can you use numbers and symbols to represent mathematical ideas? And so we're going to talk about algebraic expressions. So let me get you started with this idea. Now you can just watch this next part of the video without having to copy down the examples, but talk about expressions. So we've seen expressions, maybe like facial expressions, even in a cartoon. So if you saw this cartoon, you'd think to yourself, what are they trying to express? Oh, happiness maybe. This one over here, you can kind of see on the bottom. Maybe this one is showing scared or fear, right? This one, you can see the bottom got kind of cut off here. This looks like they're angry. Perhaps this one here looks like they're sad. And then I've got another one that looks maybe confused. So just facial expressions, how the eyes are drawn. Everything else is the same, but the eyes, maybe the mouth, some features there, kind of tell you, express different feelings. Now, let's take a look at a menu here. If I were to look at a menu of hamburgers, cheeseburgers, fries, and sodas, I could use expressions on the bottom over here to express that. On the bottom here, I bet you can tell me that that is hamburgers and fries. Over here, this might be the cheeseburger, fries, and a soda. Next one's 7 fries, so on and so forth. So these here are expressions. They express different items, right? A hamburger and fries, by just using a letter, or variables is what you'll find out. Okay. All right, so let's talk a little bit more about the real world. So in certain countries, they measure temperature in Fahrenheit. Okay, the U.S., the Bahamas, Belize, Guam, Cayman Islands, to name a few. It's basically this part of the world, right? So everywhere else they use Celsius to measure degree temperature. So sometimes we need to convert that. If you're going to be traveling south of the border, maybe up into Canada, maybe in South America, maybe to Europe or Africa, China, Russia, India, anywhere else, you better know how to convert some of these things so that if they told you it's 21 degrees Celsius outside, you're not thinking it's going to be super cold. You might know what temperature that really is. So in order to convert that, there is a equation here, a formula if you will, where C equals 5/9 times F minus 32. Well, what the heck does that mean? Well, F represents the degrees in Fahrenheit, and C is the degrees in Celsius. So just to show you an example, if let's say outside it was 77 degrees Fahrenheit, what this would look like is, what is that in Celsius, right? And what would that the rest of the world look at as? Well, you'd say, look, Fahrenheit 77, you subtract 32 degrees from that, and then after you subtract all that, you're going to multiply by 5/9. So that'd be like 5/9, and then you take 77 minus 32, which gives you 45. And then you go ahead and multiply by 5 and divide by 9. So multiply by 5, divide by 9, you end up with 25 degrees Celsius. So if you're in another part of the world and they say it's 25 degrees out today, you're not thinking, oh my God, it's so cold. No, it's actually only 77 degrees Fahrenheit, what we're used to. So that's converting it. Here's some words you need to know that you probably already know, but the first one is variable. That's a symbol, or typically a letter, that represents an unknown quantity. It could mean multiple numbers at certain points. Algebraic expression. That's an expression that contains variables, numbers, and at least one operation. Okay, so here's an example. This is an algebraic expression. It's got a number, it's got a variable, and at least one operation. Addition, subtraction, multiplication, division, something like that. So the branch of math that involves variables or letters is called algebra. Okay, so that's algebra. So if you ever hear that word, you know, what the heck does that mean? It means it's got letters involved. So here are some examples. I'll show you all of them at the same time. We've got 6D, that means 6 times D. 8WT, that means 8 times W times T. MN means M times N. B to the third, or B cubed, means B times B times B. So these are all expressions with variables and operations involved. So the other word that you should probably already know from my class, but we'll go over it again, is coefficient. That's the numerical factor of a multiplication expression that has a variable. For instance, 6 is the coefficient of this expression. 8 is the coefficient. Here you don't see one, but we know there's a 1, that ninja 1. That's my coefficient for this. Same thing here. There's nothing up front. That means there's a 1. That's the coefficient. Okay. So beware, just a little side note, be aware that W divided by 4, it can be expressed a couple different ways. this is the way that you'll see the most, and this is what I prefer, W divided by 4 like a fraction, right? The other way you could see it, maybe you've seen in the past in elementary school, you got W divided by 4 with the old division sign, okay? And then the last one would be W times 1/4, because dividing is the same thing as multiplying by the reciprocal, right? The multiplicative inverse. So don't worry if you're not too familiar with these other ones, but you should get used to this format right here. So let's get some practice evaluating expressions. Okay, so if I have this, 2 times the quantity n plus 4, if n equals -3, then this is how we do something like that. We say, look, I know what this is. I'm going to replace or substitute n with -3. That's all that happens. So n turns into -3, and then I solve the problem. I evaluate the parentheses, so -3 plus 4 is 1, and then I'm going to multiply at the end. 2 times 1 is 2. So that's the answer. When I plug in -3, I get 2 as a final answer. Let's take a look at another example. Okay, so 6w minus 2v if w is 8 and v is 4. So again, I just say, look, this is the problem. I'm going to replace or substitute the w with the 8 and the v with the 4. I do that. I then multiply, because I multiply before I subtract. And then I'm going to subtract last, giving me my answer. All right, let's try one more. Let's use one with some exponents involved here. 2 times y to the third plus 2 if y equals 3. Well, once again, I'm going to substitute. I change that y to whatever y is. In this case, it's 3. All right, then I'm going to do exponents first. That's why I go 3 to the third. 3 times 3 times 3. Okay, it's 27. 27 times 2 gives us our 54. So we would do multiplication next and then add at the very end. Add last. Okay, so this is evaluating expressions. Just means to plug it in and figure out the answer. All right, so I want to go ahead and use a real-world example here. So athletic trainers use the formula right here, 3 times 220 minus a over 5, where a is the person's age to find out their minimum training heart rate. So at what rate should your heart be beating? That at that pace, if it's going that quick, anything above that, that you're really working out your body pretty well. So use your own age, use your age, okay, your actual age to find out your minimum training heart rate. I'll use my age just for now. I'm 35, but you're going to use your own numbers. So Mr. Ramos, I'm 35. What I'm going to do is I'm going to take the formula that they gave me and I'm going to replace the A with the age. I put 35 in there. Okay, order of operations tells me parentheses first, so that turns out to 185. Then I'll multiply next, and then I'll divide. And so my final answer is 111. So this means, therefore, Mr. Ramos's minimum training heart rate should be 111 beats per minute. So if I go running, I'm trying to work out, I got to try to reach that heart rate. At that point, I know anything extra, as long as I'm not doing anything too crazy, will be very beneficial to me. So when it reaches 111 beats per minute, Mr. Ramos gets the most out of his workout or training. What about you? So what is your number? And last but not least, we're going to talk about writing expressions. How do you write your own? So when you want to translate a verbal phrase like a sentence into an algebraic expression, you always define the variable you choose to use. You got to let people know, hey, by the way, this letter means this. So let's use Gabby as an example. Gabby wants to buy a new art supplies to help her draw anime characters. She's already saved $14 and she can save $5 a week. How much will she have in 8 weeks? Okay, so right away I'm going to define the variable you want to use. So in this case, the variable is W. W is going to be the number of weeks that she saves money. Okay, so that's the unknown. That's what I want to know. How much will she have in W weeks? Well, I don't know. We're going to find out. Okay. So, how much will she have? Well, what she has, that's what we start with. We add the amount saved per week, times it by the number of weeks, and that should give me my total saved amount. So, here we go. 14 is what she had. She's saving $5 a week. Okay, how much will she save? Well, in this case, what happens in 8 weeks? Well, I get to replace W, the variable W, with an 8. Right? That's the expression, and I go ahead and replace it. So I go, let's see, multiply first, that's 40, add it to 14, and that gives me $54. So that means in 8 weeks, she's going to save $5 a week, that's 40, plus the $14 she already had, gives her $54 in 8 weeks. All right, that's it for notes today. I know it's a little long, but be ready for class tomorrow as we'll practice translating and evaluating expressions.